This surface is completely freeform, double curved, impossible to draw by hand, and it covered in perfectly placed panels. Every one sits exactly on the surface. Everyone knows the local surface direction. Not a single one is misaligned. This is the divide surface workflow. Once you learn it, you can cover any surface, any blob, any wave, any parametric form with geometry automatically and perfectly. Day 13 Surfaces. Picture a globe of the Earth, a curved 3D surface. But open an atlas and you see the same world as a flat map. Every location on the globe has a map coordinate, longitude and latitude. That flat map is UV space. U behaves like longitude, running around the surface. V behaves like latitude, running from one edge to the other. Every point on any 3D surface, flat or widely curved, can be addressed with a U and a V value, both between 0 and 1. When you divide surface in Grasshopper, you're drawing a grid on that flat UV map, then projecting it onto the real 3D surface. The grid automatically follows every twist of the curvature. Let's build a gently undulating surface to work with. In Rhino, draw 3 curves at different heights, each with slightly different shape, one concave, one flat, one convex. Type Loft in the Rhino command bar. Select all 3 curves in order, press enter and accept the default Loft options. That's our working surface for the rest of this lesson. In Grasshopper, place a surface parameter from the Params tab. Right-click it, choose Set One Surface and click the Loft surface in Rhino. Right-click the surface parameter again and choose Reparameterize. This resets the surface's U and V domain to the clean 0 to 1 range, so the UV coordinate of 0, 0 is always the corner and 0.5, 0.5 is always the center, regardless of how the surface was originally built. Place a divide surface component from the Surface tab. Connect the surface parameter to S input. Place two number sliders, integers, range 2 to 20 and set both to 8. Connect one to U input and the other to V input. Look at the outputs. Divide surface gives you exactly 3. P, the grid of points. N, the surface normal vector at each point. And UV, the UV parameter pair at each point. That's it. 3 outputs, no more. The N output gives you a vector pointing straight away from the surface at each point. Let's use it to lift the grid of the surface. Place an amplitude component from the vector tab. Connect the N output to V input. Place a number slider named offset distance, range 0 to 2, A input. Amplitude sets the length of each normal vector to the slider value, keeping its direction. Place a move component. Connect the P output of divide surface to G input. Connect the amplitude output to T input. Drag the offset distance slider. Increase it and the points rise higher. Decrease it and they settle back onto the surface. This is exactly how you generate surface offsets or set fin projections height later. To orient geometry flush against the surface, we need actual planes, not just points and normal vectors. For that, place a separate component, surface frames, found in the Surface tab. Connect the same surface parameter to S input. Connect the same two U and V division sliders, its U and V inputs. Its F output gives you the full plane at every grid location, origin at the surface point, oriented with the surface local normal and tangent directions. This is the piece divide surface alone cannot give you. Now, place a flat rectangle at the world origin. This is your source fin geometry. Place an orient component. Connect the rectangle to geometry input. For the source plane, use the world XY plane. For the target plane, connect the F output of the surface frames. Every fin follows the curvature exactly with zero manual placement. This is real architectural surface cladding generated from one definition. UV space. Why we use it? 3D curved surface has no simple grid on their own. A point halfway across a curved surface isn't halfway in X, Y or Z. UV space solves this by giving every surface its own internal flattened coordinate system, independent of the surface actual shape in 3D. What beginners misunderstand: U and V are not the same as X and Y. They are completely separate coordinate system that belongs to the surface itself, and Grasshopper converts between UV and the real 3D coordinates for you automatically. Surface normals and frames. Why we use them? A point alone tells you where something is on a surface. It doesn't tell you which way that surface is facing there or how to rotate geometry to sit flush against it. A normal vector gives direction. A full frame plane which gives direction and orientation, which is what geometry needs to be properly aligned. What happens internally? Divide surface calculates the normal by taking the cross product of the surface tangent direction at each UV location. Surface frames goes one step further and packages the point, normal and tangent directions together into a complete plane. Here now build with list, math, logic and surfaces. Day 14 is a checkpoint. We bring every one of those tools together into a single reviewed project before moving into phase 3. See you in the next one.